Hey TechnoStuds! In a prior video, I covered wildcard masks, but I briefly covered it and I said I would get a little more in depth into it. So let's get a little more in depth into it now. Now it's important to really understand what a wildcard mask is and how it operates. And not just because of the network statements that we're creating now. In fact, it's going to become more important as we go along into other modules. So make sure you get it down now. So let's get a little more in depth into what a wildcard mask is. Now we know that our IP version 4 address have 32 bits, and each of those bits is a 1 or a 0. And so if I were to represent this 10.1.10.34, I would come up with 0, 0, 0, 0, 1, 0, 1, 0. And this will be all zeros with the last one being a 1. And this would repeat that 0, 0, 0, 1, 0, 1, 0. And 34 would be represented by 0, 0, 1, 0, 0, 0, 1, 0. Let's see, is that enough zeros or enough digits there? 2, 4, 6, 8. Yes. Okay. So that is the representation, that is the binary equivalent to 10.1.10.34. So that is an IP address. What a subnet mask did is it told us which were the network bits and which were the host bits. So in this case right here, I would enter in that this was all network bits here, and that would be represented by 1. It would say that these are network bits. And same thing with this, those are all network bits. And then same thing with all this, these are all network bits. And then these are host bits. So in some senses, this is saying, well, this doesn't represent the network, or this doesn't really matter. I'm going to ignore those last ones. It's not quite what it's saying, but this is the network portion of this, and this is the host bit portion of this. And what we come up with is 255.255.255.0. A wildcard mask is somewhat similar. And a lot of times what we're going to see is the wildcard mask is the opposite of the subnet mask. So in this case right here, if we're specifying this network that this is on, we would say that these are all host bits. Or what the ones represent is it doesn't matter if that's a 1 or a 0. We're going to ignore those. It's similar to wildcards in things like programming, or in certain softwares, you'll use wildcards to say, I want to search for something, or I want to eliminate all of these options, or you use wildcards as a wildcard. And so these are all, essentially turns this into ignoring that part of it. And then these would all be zeros across here, saying that those are the ones that we are concerned about, that we want to see. So what we end up with the wildcard mask, once again, is the opposite of a subnet mask. Now I say wildcards generally are the opposite of the subnet mask. So let's take a look at why I say generally. So here's an IP address right here. And that IP address has those bits to it. And I've already said if I'm going to do the network itself, or the network that this is on, this would be the network that it's on right here. This would be the wildcard mask for representing that network, saying that all of the last bits don't really matter. So it's really anything that's on that network. However, there are times when I want to specify a single host or a single interface. And so to do that, I say that all the bits matter. There are no wildcards. So that is all zeros. So I use all zeros if I want to specify a specific host. Or in the example of our OSPF, if I want to specify a specific network interface that I want to send OSPF packets on there, then I could use these all zeros on it. All right. There are times when I want to do something greater than just the individual network. The example of this is when we did my first demo on OSPF configurations. in that case right there, I wanted to specify all of the networks and all of the interfaces. It was greater than any one subnet. So I'm calling this the summary. The summary is something that's greater than any of the any one network there. So this is all of the networks fall under here. I'm saying that it's anything in that 10.0.0.0 range, that all of the bits in that /A network are wildcard. And so any of those networks, any of those interfaces would be fair game, I guess, in that case right there. The network, the wildcard mask would include all of those.